Good afternoon, everyone. Welcome to Lab 2 in our introduction to remote sensing of the environment. Today's topic is understanding band combinations and image visualizations. As with last week, if you haven't yet signed up, please do so. You need an Earth Engine account to register, and you can access the processing environment through this address here, code.earthengine.com. The objective of this lab today is to strengthen your understanding of image visualization principles, develop practical skills in mapping band combinations, and exploring reflectance properties of surface elements. So for the lab today, we'll be using a Sentinel-2 multispectral image. Sentinel-2 is a fantastic satellite constellation from the European Space Agency. It's a wide swath, high resolution, 10 meter resolution visible range. It supports Copernicus land monitoring studies, including monitoring vegetation, soil, and water. And the image we'll be using today is collected over Kakadu National Park in Northern Australia. So let's start by navigating to the area of interest. Two ways we can do this. We can, of course, just grab the map with our left mouse, move it where we want it. But if we want a very specific area of interest, we can use this little bit of code here. Map set center with the coordinates of the location we're interested in, and a zoom level. What I mean by that, I just copy, paste that in here, and hit run. This takes us to our area of interest because I put in the coordinates that I wanted. And this 8, if I change that to a 5, it will zoom us out. I change it to a 10, it will zoom us in closer. For the purposes of today, I'm just going to leave that at 8. That zoom range is on a scale of 1 to 22. Okay, now that we're in the right place, let's choose a Sentinel-2 image. We're going to use the code below today. I've pre-selected an image for this exercise. In following weeks, we'll look at how to query the archive for a given location and date range. But for now, we're going to use an image that I've chosen. So copy and paste this script into the code editor and click run. Let's do that, and I'll talk you through it. So we're going to select a specific Sentinel-2 image from the archive. We're going to create a variable called Sent2, Sentinel-2, Earth Engine image function. This here is the name of the image. Copernicus program, Sentinel-2. This is the date that the image was collected, so 2018, April 22. And this is the date that it was ingested. These last letters and numbers over here refer to the orbit path and row of the satellite. So this will be consistent through time if we're wanting to look at exactly the same image again in the future. Let's hit run, and nothing happens, which isn't necessarily a bad thing. It means we didn't return any errors, so there's no problem in our code. But it hasn't given us any feedback because we haven't asked for any. If we want to check that it's really done something, we can print the image details to the console. Now we called our variable Sent2, so that's why I'm saying print Sent2. Running that, we'll see something happening over here in the console. It returns the image. Clicking on these drop-down arrows, we can see some information. We can see that there's 16 bands in this image, and called B1, B2, B3, over through to QA60. Now, if we want more information on that, we follow our tutorial, step number 5. If we were to type Sentinel-2 into the Google search bar here, and click on the raster dataset. This is the archive of Sentinel-2 information held within the Earth Engine environment. And there's a very useful information. So you'll see here revisit interval every 5 days. In Australia, it's about every 6 days. It's still fantastic. This table is very useful. It gives us details on each band. So band 1 through to band 12 with a few quality assurance bands. We have the spatial resolution that each band, as well as the wavelengths that it represents. Now, there's also a brief description. So we know that band 2 is the blue band, band 3 is the green band, band 4 is the red band. We have 3 bands in the red edge. Band 8 is the near infrared, another red edge band, band 8A, and some shortwave infrared bands. So this Sentinel-2 then covers a very useful range, right from 440 nanometers through to 2,200 nanometers. Can close that and have a look at our next step, which was, before we go any further, please save your script so that you can refer to it at a later stage. But getting back to our image, we learned from that table that bands 2, 3, and 4 are the blue, green, and red bands, respectively. Therefore, if we wish to view a true color rendering of the image, that is, an RGB composite, we need to place band 4 into the red channel, band 3 into the green channel, and band 2 into the blue channel. We can do this with the code below. Taking careful note of the syntax of specifying band arrangement. Map add layer, sent2, then in the curly brackets, bands B4, B3, B2. Let's hit run. You can see that something's happening in our layers tab, and we get this black square on our screen. So something's happened, which is great. It's plotted our image on the map, but why is it black? Well, it's completely dark, and that's because we did not specify any visualization parameters. Now, reflectance values for Sentinel-2 level 1 products range from 0 to about 3000. So we'll specify this in our code like I've done below here by including a minimum and a maximum value range. So let's paste that in and run it again. Now we see we have 2 layers in our layers tab. That's because I've set map add layer twice. And that's the first image. And here we have a much better looking image coming over at the top. Turn that one off. And here we have a true color composite showing the reflectance in the visible range. Now, this gives you some idea of how incredible Sentinel-2 imagery is. 10 meter resolution every 6 days and multispectral. So this image is taken in April 2018 up in northern Australia. This is the end of the big wet season, so everything's still very green. You can also see a lot of sediment coming out through these big rivers, flowing into the Gulf of the Bay over here. Okay, that's great, but that's that's sort of typical of what we would see looking out the window of an airplane. But what about looking at some features that we can't see with our own eyes? Let's go down to step 12. Actually, before we go any further, there's just a note here to clean up our code a bit. You'll notice that in these last two steps, I didn't include any comments. It's bad practice. That's why I've just put in a note here to remind yourselves to add comments so that you know what you're doing when you come back to this code in the future or when you share it with somebody else. So we'll just copy those, paste them over here. And that note, add RGB composite to map, but without any parameters defined. And that's why I'm calling it black, because it's just going to show a black square. And the second one, add RGB composite with parameters defined. And here I've put in the min and max, and that's for our true color composite. So remember that at the end of the visualization parameters, these, what I'm writing here, will become the name of the layers. So when I click run, you'll see that the layers are now called true color and black. And this relates to these. Just another little trick. If you don't want these to load up each time, you can just write false at the end here. Now when I run it, it's still generating the layer, but it's leaving it unticked. That way we don't have it constantly loading in the background. Okay, moving on to step 13. If we look back to the table of Sentinel-2 wavelengths, we can see that band 8 is in the near-infrared spectrum. Therefore, to map a false color composite, we need to put band 8 into the red channel, move band 4 into the green, and band 3 into the blue. The resulting image will really highlight photosynthetically active vegetation in vibrant red. Let's give that a go. Copy, paste, and note that I've annotated this, and I'm going to call this layer false color. Just compare that to the true color. The true color, I have band 4, 3, and 2, and now I'm using an 8, 4, 3 combination. Click run. There's the true color. Zoom in a bit. True color, false color. Here comes the false color on top. Zoom in a bit closer. And what's great now is we can use this layers tab. It's like a GIS. We can click that on and off. And we can see quite a few features which sort of jump out in this false color infrared. And just looking here, you can see these burn scars showing up very nicely in the false color near infrared image. They are present in the true color, just can't see them as clearly. They really pop out nicely in this visualization. So take some time to explore the image, move around, see what you can find. A couple of interesting things here. For example, some of these waterways in Kakadu are chock-a-block full with a weed, Salvinia, blocking up the waterways, but very green. That's why it's giving such a strong signal in the near-infrared range. Okay, I've covered that in the tutorial here on GitHub. A few reminders on how you can take these layers on and off from a visualization point of view. But to really build your understanding of how different wavelengths interact with surfaces, we're now going to look at loading individual bands sequentially from shorter to longer wavelengths. So these are going to be grayscale bands now, because we're only loading one at a time. So if we want to add just band 1 to the map, we would do it like this. Bands 1, and we're going to call it copy. Let's paste that in and run. And here we have it. So we can switch off these other two. And this is our first band. Reflecting in the water, short wavelengths, absorbed over the land. What I want you to do now is do the same again for a number of bands. I've chosen a few different ones here, band 4, band 8, band 12. You just copy that, paste it in, and you can add more. I suggest you do. You should load them all up so that you can explore how the reflectance properties of the different wavelengths change as you move from the shorter to the longer wavelengths. I'm going to turn off false and true colors, and basically as these load up, you can really see those differences. I'm going to zoom in a bit here, where the river runs into the ocean, and let's look here. I'm going to untick these. So we'll start with band 1, that's the short wavelengths. Band 4 is in the red channel, in the visible, but still quite a short wavelength, relative to, say, band 8, which is in the near infrared. This is an interesting one. So looking at band 4 here, the red band, we still see a lot of reflectance in the water. But as soon as we jump to the near infrared, we see that the water is almost entirely black because those longer wavelengths are being absorbed, and we're seeing much more brightness on the land because the green vegetation is reflecting that near infrared light. So you can learn a lot about reflectance properties by following this process. Lastly, I'll flick on band 12, that's in the shortwave infrared, much longer wavelengths, entirely absorbed by the water, not much reflection from the land. And we do see some reflectance from the soil. So please take some time, zoom out, move around the image, have a look at these different at the different individual bands, and try and understand what you are seeing in terms of reflectance and absorption. So you can use the Layers tab to turn bands off and on in the map display view. Take note of which landscape elements appear brighter and darker as you change band number, and therefore move from shorter to longer wavelengths. That's the end of the guided tutorial that I prepared for you. However, I would like you to go through this practical exercise that I've developed. So the first step is that I want you to load up another Sentinel-2 image. This is over exactly the same area, so the same time. I've provided the name for you. So it's taken from later in the year, in August, 10th of August. And I want you to visualize this image in true color and false color. I've suggested that you call it set to dry because it's taken at the end of the dry season, whereas the first image you loaded up was taken at the end of the wet season. Please compare the August image with the one from April. What has changed in the scene and why? And so far we have only explored 2 visualization options, true color, false color composites, but there are many more possibilities. And I've listed just a few ones here which are sometimes used. So have a play with these different band combinations. Have a look at which ones you think are useful for identifying different features in the landscape. So experiment with the combinations listed above and think about why we might want to use them. And then lastly, I'd like you to use this image listed here to explore a more urban setting in Sydney. So this is an image taken in the city of Sydney. You should be able to complete this exercise just by modifying the codes that we've explored through this tutorial. So that's all from me for today. Hope you found that useful, and see you next week for Lab 3. Cheers.